In this video, we're going to get ready to do some trig graph transformations. Before we do that, I want to talk about periodic functions. I want to define what a periodic function is, and I want to explain what a period and a phase shift are, as well as amplitude and vertical shift. First of all, let's look at our basic sine function. We've already talked about the domain and the range of the basic sine function. The domain is all possible x's, negative infinity to positive infinity, but the range was between -1 and +1. Those are the only values we could have for y. Well, let's look at this more closely. First of all, the graphs that you see have all been drawn with WinPlot, a shareware software package available at math.exeter.edu/rparis. A periodic function, such as our basic sine function, is a function whose graph repeats itself identically from left to right, or on the x-axis. For instance, if I look at this part of my sine function, I see that it repeats again here, and it will do that positively and negatively. Wherever you look at the sine function, you'll see this same cycle repeating itself. We can also talk about this mathematically, saying that a periodic function can be represented by f of x is equal to f of x plus some number p for all x. If I have a point here, and if I go a set distance, it repeats itself here. So the sine function is a periodic function. And we actually have a special name for that distance p. It's called the period. The period of a function is the horizontal distance, that is the distance along the x-axis, required to have a complete cycle. Here on the sine function, you can see that the period goes from 0 to 2 pi. If this was in terms of degrees, it would have been from 0 to 360 degrees. So a basic sine function has a period of 2 pi, and that's also true for the cosine function. We found that for the tangent function, the period was only pi, but right now we're only going to focus on sine and cosine. The frequency of a function is simply the reciprocal of the period. The frequency is 1 divided by the period. We'll be talking mainly about the period and not the frequency, but I did want to mention this. Another characteristic of a periodic function that we need to talk about is a possible phase shift, that is, the shift of a periodic function horizontally. For instance, right here, I have a positive phase shift of pi over 2. I take my original curve in red and shift it to the right 90 degrees, and the function is identical